Now we've looked at double angles. We're going to see that double angle formulas are not restricted to the angles 2 theta and theta. Other double combinations such as 4 theta, 2 theta, or 6 theta and 3 theta are also valid. So here are some examples. You see sine of 4 theta, we can write as 2 sine of 2 theta, cosine of 2 theta, and cosine of 6 theta is 2 cosine squared of 3 theta minus sine squared of 3 theta. So by using double angle formulas together with the sum formulas given in the preceding section, you can derive other multiple angle formulas. So here we're going to derive a triple angle formula. We write sine of 3x in terms of just sine of x. So what we're going to start with is we can write sine of 3x as sine of 2x plus x. Then we can, using our sum formula for sine, we can say sine of 2x times cosine of x plus cosine of 2x times sine of x. So sine of 2x, we know that formula. And so that is 2 sine of x cosine x. Then we have our cosine x plus, and then cosine of 2x. So what we're going to do is, because this is sine, let's use the sine form of it. So let's use times 1 minus 2 sine squared of x. And then multiply that to sine of x. So now let's go ahead and simplify. So we have 2 sine of x times cosine squared of x plus sine of x minus 2 sine cubed of x. So as cosine squared of x, we're writing everything in terms of sine. So remember, cosine squared of x equals 1 minus sine squared of x. So we'll use that for here. So this is 2 sine of x times 1 minus sine squared of x plus sine of x minus 2 sine cubed of x. So let's multiply. So this becomes 2 sine of x minus 2 sine cubed of x. And keep on simplifying. So we have 2 sine of x plus sine of x. That will become 3 sine of x. Then we have negative 2 sine cubed of x and negative 2 sine cubed of x. That simplifies to negative 4 sine cubed of x. So you try. We write cosine 3x in terms of cosine of x. Okay, if you tried this out, you should have gotten 4 cosine cubed of x minus 3 cosine of x. Now let's take a look at half angle formulas. So we have sine of u over 2 equals plus or minus the square root of 1 minus cosine of u over 2. Cosine of u is plus or minus square root of 1 plus cosine of u over 2. And then tangent of u over 2 is either 1 minus cosine of u over sine of u, or sine of u over 1 plus cosine of u. Now the sign that you use depends on the half angle. Okay, so depending on where this is, what quadrant it's in. So say, for instance, we are at 68, for example, that is in quadrant 1, right? If you're looking at something that's 290, for example, that's in quadrant 3. So the sign depends on what you're looking at. So what is the sign value in that quadrant? And we're looking again at that half angle. So here, find the exact angle of sine of 105 degrees. So that is the half. And so what we want is the full angle. So the full angle, so 105 degrees times 2, that is 210 degrees. So we're finding sine, so let's use this one. So it's sine of 105 degrees equals the square root of 1 minus cosine of 210 degrees all over 2. So the sine value at 105 degrees, that is here. So the sine value is going to be positive, so we're only taking the positive sign. So now we evaluate. So 1 minus cosine of 210 degrees, so you have to think about where that is. 210 degrees is here. And so that is, how far is that? That is 30 degrees from the x-axis. So the x value there at 30 degrees is negative root 3 over 2. And then that's all over 2. So then we need to simplify. So this is the square root of 1 plus root 3 over 2 all over 2. So let's multiply by a square root of 2 over 2. So we can rationalize the denominator. And so you get the square root of 2 plus root 3 and then all over 2. Okay, let's try this next example right here. Find the exact value of cosine of 105 degrees. So remember that cosine is negative at 105 degrees, so we're going to take the negative sign here. And then you're using the 1 plus cosine of u all over 2, so u is 210 degrees, because half of that is 105. And then you rationalize the denominator, and so you would get negative square root of 2 minus square root of 3 all over 2.